In this video, we are going to learn how to use graph to solve problem in exam. Now, this is an example of force versus displacement graph, where you have the force on the y-axis and displacement on the x-axis. Now, there are two things you can find from a graph. First is the slope of the graph, and second is the area under the graph. Depending on what they ask you in the question, we can use any one of these to find our answer. So if you have force versus displacement graph, the area under the graph will give you the work done. So if I find area under the region of the graph, this area gives me the work. So in question, if they ask you for this force displacement graph, find the work done by the force. Work done by the force will be given by taking the area under the graph. Now, if this was the case of spring force, if the force involved here was spring force, so we write F and X, and if this force was spring force, the slope of the graph will give you the spring constant K. So if this was specifically for spring force, the slope of the graph will give me the value of spring constant, which is K. And depending on what the question is asking you, you can either use the slope or the area under the graph to find the quantity they asked. So let's take an example. Question 6.78 is asking you that they have a graph shows the component of F cosine theta of the net force that acts on a 2 kilogram block as it moves along a flat horizontal surface. Find the net work done on the block and the final speed of the block when it starts from rest at s equals 0. Now let's start with part A. In part A, they want me to find the final net work done on the block. So we know that work done can be found by taking area under the graph. So since this is a force displacement graph, I can find the net work done by taking the area under the graph. So I need to take area from the region starting from 0 until 8.0. You need to find area under this region. So let's divide this region into separate parts. I will call the region from 0 to 1 as 1, from 1 to 5 as 2, this will be 3 and 4. So if I want to find the net work done, I need to find area under each of these regions, W1 plus W2 plus W3 plus W4. Region 1 and 4 are flat lines on the x-axis. So they are not covering any area. And work done by this region will come out to be 0. So to find the net work, I need to find what is area under the graph for region 2 plus region 3. So this is the area we are looking at. For 2, this is the region. I need to find this area. And for 3, it's over here. Now, since both of these figures are rectangle, when I take the area, I will take the area of the rectangle, which you can write as base times height for 2 and base times height for 3. So base for region 2 it starts from 1 and goes until 5. So my base will be difference between these two values, 5 minus 1. And the height is 2 Newton. For region 3, my base starts at 5 and it ends at 7. So the base will be difference between these 2 points. And the height will be -1. You need to take the values as they are given on the graph. If it is negative, you have to take it negative. Don't convert that negative to positive. Take them as mentioned in the graph. And when you solve this, you get your work done as 6 Joule. So anytime they give you force displacement graph and they ask you to find the work done, all you need to do is take the area under the graph. And this area must be in the region that they specify, only the region that they specify. Since in this question they asked me to find the network, I took the whole region starting from 0 going until 8. But if they had said find the work done between points S equals 3 meter to S equals 5 meter. If they had said something like this, then I will only find the area under the graph between these two regions, 3 and 5. I will only look at this region in the graph and not go beyond that. That will be my work done from S equals 3 meter to S equals 5 meter. So only take area under the graph for the region that they specify. Now let's go to the next part of the problem. In the next part, they want me to find the final speed of the block. I have already calculated my work done. So I'm going to use work kinetic energy theorem to find the speed. So let's start with part B. We know that from work kinetic energy theorem, work done is equal to change in kinetic energy. And this change in kinetic energy I can write as final kinetic energy minus initial kinetic energy. Now, since my block starts from rest, at rest my velocity, the initial velocity will be 0. And if initial velocity is 0, initial kinetic energy will also be 0. So we can rewrite this expression, work done is equal to final kinetic energy. So work will be equal to half mv final squared. And we can rearrange this term to write for v final. We will multiply by 2 and divide by m. Then take the square root. Now we can substitute v final equals square root. Work we have already calculated in part A, which is 6 joules. Divide by the mass, which is 2. And when you calculate this, you get your v final as 2.45 meter per second. You can also use shift solve at this point to calculate your v final. If you're confused on how to rearrange, this is the step where you substitute the values. We have the work, we have the mass, and you can use shift solve. But I would recommend that you follow through the steps, write the steps, and get your answer. But if you are confused on how to solve further, you can use shift solve at this point. Next comes the graph of force versus time. When you change what is on the x-axis, what you get from the graph also changes. So in case of graph of force versus time, again we find the area under the graph to find a quantity. And that quantity now is impulse. For a graph of force versus time, area under this graph will give me the impulse. Which is equal to G. So in questions where they want you to find impulse using force time graph or final velocity using force time graph, you will be finding the area under the graph. So let's take an example. Here you have a force acting on a 4 kilogram object. And this force changes with time as shown in the graph. What is the velocity of the object at t equals 3 seconds? If it starts moving with the velocity of 2 meters per second. So now in this question, they have given me the mass of the object, which is 4 kilogram. And they have given me the time, and they have given me the initial velocity of the object. They want me to find what is the final velocity at time t equals 3 seconds. To find the final velocity, we are going to use the impulse momentum theorem. Impulse momentum theorem says that impulse J is equal to change in momentum. And this change in momentum we can write as m v final minus v initial. So I can find my v final by solving this equation. And before we solve this equation, let us first find what is our impulse. Now, impulse is equal to area under the graph, area under the force time graph. So since I want to find velocity at time t equals 3 seconds, I'm going to take area under the graph until the time 3 seconds. So I'm going to take this area. This figure is a triangle. So when I find the area under the graph, I basically need to find the area of the triangle, which is half times base times height. That will give me half. The base of the triangle is from 0 to 3. So that will give me 3 seconds. And the height is 6 Newton. So we write the base of the triangle is from 0 to 3. So 3 seconds. And the height is 6 Newton. So we write 3 times 6. And that gives me my impulse as 9 kg meter per second. Now I can use this impulse in my main rule that I got here. We need to find what is V final. So we rearrange this term to write in terms of V final. First, I will divide by M. J over M equals V final minus V initial. Then I will add V initial on both sides. So V final equals J over M plus V initial. Now substitute impulse we found as 9. Mass is 4. V initial is 2. And when you solve this, you get your V final as 4.25 meter per second. So this is how you use graph to solve problem. The two most important things you can use from the graph is its slope and the area. And depending on what kind of graph it is, what you're finding from the area will change. If it is force versus displacement, area under the graph is work done. And if this force was spring force, slope of the graph will give you the spring constant. If this was force versus time graph, area under the graph will give you impulse. And from the definition of impulse, we know that this will also be equal to change in momentum. So the things that you can find from graph is either work, impulse, change in momentum, and by the definition of momentum, you can also find velocities.